Hello, in this video we are continuing our discussion of section 8.6. Specifically, we're still working through example 3. We have already worked through parts A and B, so in this video we're going to do part C. So we are given the function 1 over 2 plus x. We're asked to find the power series representation and interval of convergence for that function based on the geometric power series that we're given. So just like in parts A and B, we need to relate this function in part C, which is 1 over 2 plus x, to the function relating to the geometric power series that we've been given. So the first issue that we have is the fact that we have a 2 in the denominator instead of a 1. So what I'm going to do is factor a 2 out of the denominator so that we get something like this. 1 over 2 times the quantity 1 plus x over 2. So I could write this as 1/2 times the function 1 over 1 plus x over 2. So this is closer. We have a 1/2 times a function that's closer to that, but we need a minus in there. So I'm going to write this as 1/2 times 1 over 1 minus a negative x over 2. And now that looks a lot more like the function that we are given. So we have a constant, which is fine. We can account for that. We have 1 over 1 minus, and then we have some function of x in here instead of just simply x. So essentially what we're going to do is we're going to substitute in a negative x over 2 for x and multiply by 1/2. So 1 over 2 plus x, which is the same thing as 1/2 times 1 over 1 minus negative x over 2. This is going to be equal to 1/2 times the sum from k equals 0 to infinity of now we do the substitution, negative x over 2 to the k. We can go ahead and simplify this a little. We'll have a 1/2 sum from k equals 0 to infinity, negative 1 to the k, x to the k over 2 to the k. And since we have a 2 outside of the denominator, I'm going to go ahead and bring it in here and combine and add 1 to the power. So we end up getting the sum from k equals 0 to infinity of negative 1 to the k, x to the k, and I'm sorry, that should be a k there, x to the k all over 2 to the k plus 1. So there is our series. To find our interval of convergence, we're going to go back to this first time that we wrote the series here. Okay, we could, let me see, for the interval of convergence, we could take our 1/2 sum from k equals 0 to infinity of negative x over 2 to the k. If we pull that 1/2 in, we have 1/2 times negative x over 2 to the k. So now we have a geometric series. This is our a value, this is our r value, but it is still geometric. And in fact, our interval of convergence doesn't actually depend on the a, it just depends on the r. So this is geometric with r equaling negative x over 2. So it converges for absolute value of negative x over 2 being less than r, and that's the same thing as saying the absolute value of x all over 2 is less than 1. And I said r a second ago, but I meant less than 1. So this means that the absolute value of x is less than 2. If you want to, you can leave your interval of convergence like this, or you can write it as negative 2 less than x less than 2. So in summary, we have 1 over 2 plus x. This is equal to the sum from k equals 0 to infinity. You could really write any one of these series formulations that you wish. I'm going to go ahead and write this last one. So that's going to be negative 1 to the k, x to the k over 2 to the k plus 1. And I'm going to go ahead and write the most succinct form for the interval of convergence. So that's the absolute value of x is less than 2. But again, it'd be perfectly fine for you to write the interval of convergence as -2 less than x less than 2. So we have our function, our power series representation, and our interval of convergence for part C.